So we're still in 2007, which I remember from multivariable calculus. So this might be an entirely different class. But we'll see how it plays out, at least into the intro, about some of what is out there in standard models. I don't know whether this did come first in the lectural thesis over the model. It may have come second. 18 to the standard on here isn't exactly the purest of codes given the system offhand, but it may be. Those single variable might be 16 if I remember correctly. I've seen something on the way back end of it on which is weird for the dot product inside of here for
Creative Commons license. Your support will help MIT OpenCourseWare continue to offer high-quality educational resources for free. To make a donation or to view additional materials from hundreds of MIT courses, visit MIT OpenCourseWare.
You got a whole stable full of dudes doing exactly the same thing you're doing on the same single variable calculus sheet of product rule on what that does. Sometimes that's different when you start running multiple saws, torches, 5-footers, the pythons there, or the Italian gantries. Then there's different multivariables on single variable graphs of pulling rocks from saws if I'm not the main sawyer, or burning billets, or pulling them down. It's Brownie Factory given what it is for the acid test. So like I said, you're going to find not just that individually hammered you with the Lagrangian standard model from our starting position, but would it matter necessarily given the end result or the dot product for this
look
angle,
at this from
that
several
angle,
different points of view.
and theta
And
angle. Angle in
the
general
first one is the geometric
45,
interpretation.
and I want to determine the x, and I want to determine the y.
And that's what we'll spend most of today
on. As much
on.
single variable calculus
And
as much as from
then
the topology
we'll also
of understanding
talk about
of
a physical
calculus.
interpretation
So causality begins to collapse a little bit, and like I said, we begin to chase
of what
the
a
same
derivative is.
product on the geometry and physical interpretation here. That geometry has multivariable chess games.
There's going to be something else, which
still
I
divergent
guess
Euler
is maybe
numbers
the
off of
reason
that.
why calculus is so fundamental and why we
And
always
he will.
start with it.
And so, like I said, it's beautiful when you can
in
build
most
tit for
science and
tat
engineering
n1
schools,
half
which is
fy over x for
the
you guys as
importance
students. Behind
of
real
derivatives of this to all measurements. So that means pretty much every place. That means in science, in engineering,
Sagittarius A star constellation,
in economics,
the geometry,
in political science.
To do it. Well, when you look at the graphs n1 half, you can get one of those crazy ass. Right along with the Hadron Collider,
just about
on a
everything.
circle, right?
So that's what we'll be getting started with. And then there's
the
another
physical geometry
thing that
of
we're
it,
gonna do
given the banking
in
and
this unit,
magnets, electromagnetism,
which is we're going to
electricity,
explain
electromagnetism,
how
magnetism,
to
same change
differentiate
flip
anything.
in curvature. Would be the spin that I'd give you for that, because it has the same topology with dealing with the crystal hippie chick, figuring out FMA. Or him being a granite obelisk, Tony. I'm harder than a granite obelisk build is what I usually like.
But let me just give you an example. If you want to take the derivative, this we'll see today as the notation for the derivative of something, of some messy function like e to the x arctan of x.
That's the front.
We'll work this
the
out.
Particles on there for the Tan Army, with the calculations against Sun Tzu and the generals.
Right?
The
So
strong force, the weak force, electromagnetism,
we can
and
differentiate
gravity. You can break it down right there if
All
you
right,
need
so that's
to.
what we're going to do.
Put your name here, say I do that in that area.
As I said,
equals
we're going to spend most of our
his
time
form, because like I said, I'm going to hit you with my form.
geometric interpretation.
When I had to find one for the saw, what the cut coefficient is, what the organization of those things are. As much as I kind of had the loose let things of this how the saw program works,
here we go with the
turns into something much more comprehensive.
Interpretation.
But the forms are still snowflakes, or still whatever he's about to hit you with it for the main course that I'm learning at some point. And eventually, even by brute force, sunshine, particles hitting you.
What we're going to do is just ask the geometric problem of finding the tangent
This
line.
is a game to tap the cobra after all. First round, set inside here, get the eraser out there. Well,
To
catch you on the next one.
some